Okay, so in my pursuit of overclocking, what I finally decided to do, I should have done it a while back, is I just hooked up an oscillator um, directly into the clock. So I've taken out the resonator, and I'm just feeding the calculator with a sine wave. Into the clock generator, which works great, and I can now set it to any frequency I want to see how the overclocking works at that frequency. So, and then run tests. What I'm sitting at now is 560 kilohertz. You can see the sine wave on the bottom of the scope, and on the top is the actual X1 clock going to the chips. So right now it's in idle, which is it has a whole bunch of clocks that it doesn't do, and then one clock. That's an idle mode for it. So what I'm going to do is I'm going to go ahead and I'm going to feed it the standard diagnostic program, and then we're going to run it. So you can now see that the calculator is really working. It's in run mode now, and it's finished, and it passed that test. What I'm now going to do is I'm going to run the SBR equal from the master module, which is actually a pretty good test, and it does stuff that's pretty intense. So I'm going to go ahead and run that now. Okay, so that's running now. You can see that now the X1 clock is going at full tilt. And then and it's churning along, and it comes up with the right answer, which is 1. So this calculator, this particular one, because each one is different in its overclocking, is working fine at 560 kilohertz. Now what I'm going to do is I'm going to increase that frequency to 570. Okay, so now we're at 570 kilohertz. You can also see these numbers up here in the display as well on the scope. Okay, so now what I'm going to do is I'm going to do the same thing, but at 570 kilohertz. Okay, well, it read it. Okay, we're going to run the standard diagnostic. Everything looks good there. So now I'm running the master module diagnostic. Miraculously, that worked. That doesn't always, I've already tried this a few times, doesn't always work at 570, but let's go a little higher. Okay, so there's 575. Okay, already that's not reading. Okay, it read that time. So now standard diagnostic fails standard diagnostic. We'll try it again. Nope, solid fail on the standard diagnostics. Now I'm going to try to run the master library diagnostics. So it started them. Still got flicker, so it's still working on it. Uh-oh. Oh yeah, so we failed that as well. So it doesn't work for sure at 575. Let's back it to 570 again. Okay, so there's 570. No problem reading. Whoops. Let me reset it. Okay. Standard diagnostics. Seems fine. Let's do it a couple times. Whoops. So as I said before, the 570 was a little unstable. 560 though seems stable, so let's back down to that. Okay, there's about 560. Okay, standard diagnostics at 560. No problem. Let's do it again. Okay, no problem. Let's do the master library module. So that's master library module diagnostics. And that's all good. So, so it's pretty easy this way to really figure out where the calculator begins to lose its mind. Now, these are quick checks. The real trick is that I really got to run it for long periods of time to look for subtle changes. But I think that this was my worst calculator for overclocking. This is the one that is the lowest frequency. I can get to 575, even 580, and on other calculators without seeming too much of a problem. I can even get to 600 on a couple of them. But so this was my worst one. So so I think that 560 might be a reasonable target, and there are ceramic regulators out there that you can still get that are 560. So this might be a good target frequency. So of course I got to continue testing and do all that stuff. But anyway, so yeah, I finally got to the point where I just needed to really check it. So anyway, and so how I'm doing that is I ran some wires inside and hooked up directly to the chip on the inside. So I've got some external wires that I can feed in a clock. Anyway, so things are continuing.